given that a pair of natural numbers are a solution to this divisibility statement. Another way to state this is to write down the quantity 5a plus 5b, or plus 13b, and this perhaps is a more conventional way of seeing this or thinking about it, I guess. But it's saying that when you reduce this fraction and without knowing what a and b are, you're going to get a natural number back. Okay? So this and this are equivalent. Now, so we're given this statement, 29 divides this sum. We want to show that this is enough to prove that 29 divides this sum, which is certainly different than this sum right here. Okay, now let's see how that might go. Now I'm going to do it using modular arithmetic. What we're given, 29 divides the expression, is equivalent to the expression is congruent to 0 modulo 29. And another way of stating that is it's just 5a plus 3b is a multiple of 29, which would follow immediately from this yet third way of expressing all of this. So there's at least three ways to talk about divisibility in this context. Okay, so we're going to work from here, and we're motivated to add what we're looking for to both sides here. Okay, and that's exactly what I did. I added 15a, or I added 10a minus 3b to both sides of this because that gave us what we're looking for. In other words, this right here, 10a minus 3b, when you add it to 5a plus 13b, you get the expression we're seeking, okay? But you have to add it to the other side, and you see 0 was on the other side, so you get 10a minus 3b on this side. So far we have 15a plus 3b is congruent to 10a minus 3b modulo 29. But notice that, and this is very, very convenient right here, minus 3 is congruent to 26. Okay, and again, I won't write down mod 29, but that's mod 29. There's a difference of 29 between minus 3 and 26. 26 minus negative 3 is 29. However, you just think on the number line, they're 29 apart, right? Okay, so we can replace this with 10a, and it's nicer to work with a positive number in this sort of setting, in my opinion. Okay, so we can replace minus 3 with what it's congruent to, mod 29, which will be plus 26b. And again, we are dealing modulo 29. But notice another way of writing this, we know that this is a given condition right here. Okay, well, this is equal to, did I write b there? Yes, that's 23b. Okay, notice that this is equal, though, not equal but congruent, both actually, to 2 times 5a plus 10b. Okay, 5a plus 10b. What did I say? 13b. Okay. But guess what? That's posited as being congruent to 0, right? So we get that this whole thing is congruent to 0. But that proves our result, okay? We wanted to prove that 29 divided 15a plus 10b, but that's exactly what this does because this is mod 29, right? So we can gleefully write down QED right now. Now, so we are done with the problem, folks, just by doing a few manipulations with modular arithmetic. Now, and I'm just checking I got this right, didn't I? Factor the 2 out of here, yes, okay. Now, think about how you would have done this if you weren't armed with modular arithmetic, okay? What you would have to do here is write down something like 5a plus 13b is equal to 29 times m, let's say. Okay, 5a plus 3b would be 29m, where m is another integer. And then sometimes you'd have to do manipulations to get it to this, where you recognized it as 29 dividing 15a plus 10b. Modular arithmetic, all these things that I'm doing at the modular arithmetic level, treating it like equations, is justified, from first principles. If you take a number theory class, you can prove why treating divisibility like an equality actually works. Otherwise, if you don't know that, if you haven't seen that, or you're not familiar with that, you have to go back to sort of a caveman approach. And what I mean by that is you would have to write 5a plus 13b equals to 20. That would be all you have to go with, right? Equals to 29 times some integer, right? I mean, that's it. That's what this statement literally means. That 29 is a divisor of this expression, and so that means there has to be another divisor called m that you multiply the 29 by. Okay, then somehow or another you would have to manipulate this to get to this form just with this. So I'm not even sure right off if I could do that. Maybe there's a way. I wouldn't know. I don't know. You know what I mean? That shows you how powerful modular arithmetic is. All right, and again, all these things about adding, multiplying, congruences are proven from the first principles of what congruence actually means, how it's actually defined if you take a number theory class. So again, quite a bit of power packed into treating divisibility like an equality setting. Okay, that's all.